All right, let's read these directions. Find the value of y at the point of intersection of the lines produced by the equations, given y equals 5 plus 2x and x equals 3y minus 20. So let's make sure that we understand what the directions are asking us to do. The directions are asking us to find the value of y at the point of intersection of lines produced by these equations. So remember that an equation, when it has two variables like a y and an x in it, and the only math that's happening to those variables are addition or multiplication, like this 2 times x, or subtraction or division, then an equation like that produces on a graph, if you were to graph it, a straight line. Now we have two equations, and this equation also has an x and a y in it, and just multiplication and subtraction, no division or addition, but if it did, that's fine. So that also is going to produce a straight line if we were to graph it. By the way, the other things that could be happening to these variables are things like exponents. We don't have exponents, so if we had exponents, it wouldn't be a straight line. But we've got two equations that each produce a straight line. That's the lines that they're talking about. Point of intersection just means, intersection means where do they cross? That's what intersection means. And point of intersection is just that point right there where they cross. So we want to find the value of y at that point. Well, remember, a point on a graph has coordinates. And those coordinates have two parts. There's two coordinates, an x coordinate and a y coordinate. So we're being asked to find just the value of that part of the xy pair of coordinates of this point, where two lines that, if we graph the equations, where they would intersect or cross. Value of y. Okay, so there are three methods to do this. Keep in mind that two equations is called a system of equations, and to find the x and y coordinate is often called solving the system. So to solve a system, there are three options that we have. One is graphing, which we've visualized here, but we don't have any graph paper, so not a great option. There's no decimals or fractions in here, which means that graphing might be sort of easy. You would need to graph numbers maybe potentially as big as 20, and so I don't know, that seems a little bit hard. I don't have a ruler or anything, so I'm not going to graph it. The other two methods are combination and substitution. Now, how do we decide between the two of them? Well, combination works best when you have your equal signs lined up. If everything else in the equation lines up where the y's line up and the x's line up and the numbers without any variables line up. So that's not happening here. We've got a y and an x. So we would want x's and y's and numbers. We've got a y and an x lined up, and a number and a y lined up, and an x and a 20 lined up. So we're not going to use combination. Substitution is the third method mentioned, and it works best when you've got a variable all by itself on one side of an equal sign in one of the equations. Well, here we've got a y all by itself on the left side of this equal sign in this first equation. We've also got an x all by itself on the left side of the equal sign in the second equation. So when that happens, substitution is a good method to solve. So not graphing, not combination in this case, we're going to use substitution. Now we have our choice. So first of all, substitution just means that you're going to plug something in for something else. Just like when you have a substitute teacher, they come in and they replace your teacher for maybe a day. So substitution, we're going to take what x is, like x is 3y minus 20. We're going to take that 3y minus 20. We're going to substitute what x is in for x in the other equation. Or we could do it this way. We could take what y is, 5 plus 2x, and we could take that 5 plus 2x and we could substitute it in for y in the other equation. Now, we want to find the value of y. And so what we want is we want to end up with y's when we're done. So let's take a look at how this works. I'm going to choose this second equation, and I'm going to take, so first of all, let's just rewrite it. I'm going to take this stuff, which is what x equals, 3y minus 20, and I'm going to substitute it into the other equation, where the x was. So I didn't write an x. X equals this stuff. I'm going to take that stuff and I'm going to substitute it in where the x was. And so instead of x, it's 3y minus 20. So why did I take this stuff and substitute it for x? Why didn't I take the other stuff and substitute it in for y? So for example, I could have started with this equation, y equals 5 plus 2x, and I could have taken this stuff and I could have substituted it in for the y in the other equation. Okay, so these are two different ways that I could do this first step of substitution. I could substitute this stuff in for x, or I could substitute this stuff in for y. Well, the directions ask us to find the value of y. So if I do this method, I have the y variable remaining, and when I just have one variable in an equation, I can reduce, simplify, and solve for y and find out what y is. In this equation over here, all I have left is x. So if I were to continue working on this one, I could solve for x and find out what x is. Because we want to find out what y is, I want the equation that has the y's still in it, and then I'll solve for y. So doing this method is okay, but doing this method will get us more quickly the answer that we want, which is y. Okay, so there are a lot of numbers and variables all over the place in this equation. There's a 5 here and a 20 here, and there's a y over here, and there's some y's over here. We want to simplify to get the y's all just in one expression and all the other just numbers just in one expression. Okay, so what we're going to do is y equals 5 plus, we're going to distribute the 2, which distribute means multiply. So we're going to multiply, and it's actually a positive 2 times a 3y, and that's a positive 3y. And a positive 2 times a positive 3 makes a positive, I already wrote that ahead of time, 6 times y. Now, if we knew what y was, we'd go ahead and multiply it. 2 times 3 makes 6 times something else, and we would write the answer to all three of those multiplied. But because we don't know what y is, we can't multiply it, so we just write times y. We're going to do the same thing. 2 times negative 20. Distribute, that means multiply. Positive 2 times a negative 20. Positive times a negative makes a negative, and a 2 times a 20 makes a 40. Okay, so I've simplified a little bit. I still have numbers in different places here, so I'm going to simplify that. Y equals, now remember that this is a positive 5. Anytime that you don't see a sign, it's a plus sign. And this is a negative 40. Remember that the sign goes with the term to the right. And so a positive 5 and a negative 40 added together or combined makes a negative 35. And then plus 6y. Okay, so now I still have y's in different places on this equation, so I'm going to need to simplify by getting the y's just to be on one side of the equal sign. And to do that, one way that I could do it is I can subtract this y away from this side, and then whatever you do to one side of the equal sign, you have to do to the other side of the equal sign, and so I'm going to subtract y from this side. I could have also done it the other way around. I could have subtracted 6y from each side. That's fine. I like doing this way because a positive y and a negative y make a nice 0. And so 0 equals, that's just very simple on the left side, negative 35, and then combine these two or add them together, right? And so a positive 6y and a negative, remember that's a 1. Anytime you don't see a number, the digit is an invisible 1. So a positive 6 and a negative 1 make a positive 5, and still y is what we're multiplying by. Okay, so just a reminder, if you have 6 of something, you take 1 of that something away, you have 5 of that something, and the something that we're counting is y's. That's one way to think about combining. Okay, so now we have our numbers all in one place on this side of the equation, and our variable expression all in one place. There's not more than one y as there was before. When that's true, so we've simplified, now we can solve. And remember that when you solve an equation, you ask the question, what's happening to the variable? What's happening to y in this case? And then you undo everything that's happening to it. And you do that using PEMDAS, the order of operations, backwards. So when you're simplifying, you use PEMDAS forwards, P-E-M-D-A-S, but now that we're solving, we say what's happening to y, we use PEMDAS backwards. So we're going to start from the bottom here. Well, is y being subtracted by anything? Well, you see this minus sign over here. Yeah, you could say that that's being subtracted, or you could say it's being added by a negative 35. So if we rewrite these two expressions, if we just swap them around, let's just do that. Remember, commutative property, you can take an expression and another expression and you can swap them or move them around. So we've got this positive 5y. You can just write 5y. You don't need the plus sign. We've got a negative 35. And so now we can more easily see, yeah, y is being subtracted by 35. So we're going to undo subtraction by using the inverse operation, which is addition. So we're going to add 35 to get rid of it. But whatever you do to one side of an equal sign, you have to do to the other. So we're going to add 35 to that side. And that gives us, line up the equal signs, 35, 0 plus 35 is 35, equals 5y. Remember, you don't have to write if it's the first term on one side of an equal sign. You don't have to write the plus, it's assumed. And then negative 35 plus 35 makes 0. And so there's nothing left there. The only reason that we write 0 over here is because it would look funny if there's nothing on one side of the equal sign. So we write the 0 to remind us that we didn't just forget to write something. But over here, we've got 0. We still have something to write, so we're okay. We don't have to write plus 0. Okay, so we've undone subtraction by using addition. Is y being added by anything? No, so we don't have to worry about that. Is it being divided by anything? No, it's not being divided. Don't have to worry about that. Is it being multiplied by something? Yep. Y is being multiplied by 5. And so we're going to undo multiplication using the inverse operation, which is division. Inverse of multiply is divide. So we're going to divide each side by 5. And so 5 divided by 5 makes 1, and 1y makes just y. You don't have to write the 1. And then 35 divided by 5 makes 7. So now we're done solving. Let's go back to the directions. Find the value of y. Well, we have found the value of y. So what we've identified is that where the lines would cross if we graph these two equations, the y coordinate is a 7. So we know that the coordinates are something for x, comma, 7. We haven't found the x. That's okay. Directions just wanted y. And so we're done with this problem.